Lesson 1-3, Speed and Velocity Graphs. Speed is the rate of change of distance. Rate of change means we're going to be dividing, so our average speed is the distance over time. Notice the variable for speed is v. So we could rewrite it as distance over delta t. Delta t means change in time. Speed is a scalar, which means there's no direction, just a size. That's because distance is also a scalar. It's because distance is a scalar, the speed is a scalar. Velocity, on the other hand, is rate of change of displacement. Notice the variable for the velocity is v. Average velocity is the displacement over time. But displacement is delta d, or df minus d0. So our average velocity would be df minus d0 over tf minus t0. Because displacement is a vector and has direction, velocity is also a vector and has direction. And instantaneous velocity is the exact velocity at a given moment. A coyote walks east 2 kilometers, so it'll be that way. Then turns around and walks back west 3 kilometers. This trip takes 1.5 hours. What is the coyote's average speed? Well, average speed is your distance over time. Our distance would be the 2 kilometers plus the 3 kilometers because direction doesn't matter. It's just the total distance. And our time is 1.5 hours. So it'll be 5 kilometers over 1.5 hours, which is 3.33 kilometers per hour. If a coyote walks 2 kilometers east, then turns around and walks back west 3 kilometers, and the trip takes 1.5 hours, that's our time, what is the coyote's average velocity? All right, so velocity is our displacement over time, or df minus do over our time. So if we start here, we could call that 0. Then we'd end at -1. So our ending point is at -1 kilometer. Started at 0. And our time was 1.5 hours. So that'd be -1 kilometer over 1.5 hours, or -0.67 kilometers per hour. But since our problem is in east and west, we probably don't want to leave it just as a negative. So our best answer would probably be 0.67 kilometers per hour, in which direction? Well, he ended up negative, which is west of the starting point. A black bear at top speed can run about 13.5 meters per second. If its friend is 50 meters away, how much time does it have to prepare for a bear hug before it gets there? Well, let's see. That is speed. 50 meters would be our distance. And we're looking for time. So we could just say average speed is our distance over time. Now how do we solve this? Well, the t is in the bottom, so what we could do is make this a fraction and cross multiply. So I could have 13.5 meters per second times t equals 50 times 1. And then divide, so 50 divided by 13.5 is about 3.70 seconds. Not much time to escape from the bear hug. Now what if we graph our position in time? So when we have a position versus time graph, the y-axis is the position and the x-axis is time, because the x-axis is always the independent variable. Time runs along independently of everything else. So as the dog moves across the screen, his position increased with time. So the graph is going up because he keeps going further and further from the side of the screen. His position keeps getting higher. Slope is rise over run. In this graph, the rise is our position and the run is the time. So it'd be our change in position over our change in time. Oh, change in position over change in time is velocity. So the slope of a position versus time graph is the velocity. So I just look at this graph, find the slope of it, and that would tell me how fast the dog goes. If the graph is curved, then you'd use the slope of the tangent line at the given time. So, for example, at P, I would draw my tangent line and get the slope of that tangent line. Or at Q, I'd get the slope of that tangent line. And that would be the instantaneous velocity at that point. The graph shows the distance a car is from its house. What is the velocity of the car at 5 minutes? So this is a position versus time graph. And I want the velocity at 5 minutes. All right, since it's a position versus time graph, I need to find the slope. So this is a straight line, so I can just find the slope of this line. So I could use that point, because I can read that it is 4/8. And I can use that point because I can read it is 0, 2. So our velocity is the slope, which is our y2 minus y1 over x2 minus x1. Now technically, that's df minus do over tf minus to. So it looks like it's 8, and that unit was kilometers, minus 2 kilometers over 4 minutes minus 0 minutes. So that gives me 6 kilometers over 4 minutes, which is 1.5 kilometers per minute. This graph shows the distance a car is from the starting point of a race. What is the velocity of the car at 3 seconds? Since this is a distance versus time graph, I need the slope of the line. But this line is curved, so I need to draw a tangent line. So I'm going to grab my ruler and make a tangent line at 3 seconds. Now I'm going to pick 2 points on this tangent line. Maybe that one and that one. This point I'm going to guess is about 2 and 15. This one is 4 and about 73. So then our velocity is our change in distance over our change in time. It's the slope of this. So that would be 73 meters, so units in meters, minus 15 meters over our times, which are 4 seconds and 2 seconds. Just give me 58 meters over 2 seconds, or 29 meters per second. So at the time of 3 seconds, the car is traveling at 29 meters per second.